Hello everyone, today I will solve the question number 42, trapping rainwater, and the question statement is given n negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So we need to return the total water in unit, how much we can trap after raining. So you can assume these integers as a boundary, so they will give us a boundary integer value, and we need to return this water quantity, how much we can store after raining. So let me explain you one thing first. So for this unit of water, for this index, how you can calculate, you can see the maximum left is 2, right? The boundary of maximum left is 2 and the boundary of maximum right is 3 and maximum left is 2. So if you will increase water, if you will store more than 2, it will overflow, right? Because the minimum is 2, boundary is 2, so you can store till 2, and the height of this index is 1 because you cannot store 1 unit of water. So you can store 1 unit of total 1 unit of water at this indices. Like here, maximum left is 2, maximum right is 3, right boundary. So you can store till 2, and the height of this indices is 0. So the total 2 units of water you can store. Here maximum you can store 2, height is 1, so 1. Here also maximum left is 3, but maximum right is 2, so you can store till 2, and the height of this index is 1, so 1. Here also same 1, so you can store 2, 3, 4, 5, 6, total 6 unit of water, right? So our solution will be comprised of the basic idea, that is the left boundary, right boundary, minimum of left boundary, right boundary minus index, height of this index. It will be the basic idea of our solution for calculating the stored water. So I will explain you, and I will give you 3 solutions. First will be the time complexity of n square. Second will be the time complexity n, but the space complexity will be also big O of n. And the third will be the most optimized, that will be time complexity of n, and the space complexity will be big O of 1. So in the first solution, what we will do, we need to get the maximum left and maximum right of each index, and we will decrease the value of height of that index, right? So we need to calculate the maximum left and maximum right of each index. So first we will iterate on each integers, and we will run a for loop for the maximum right and for the maximum left. When our iteration will be on first value, we will run a for loop for the maximum right and we will get 3. Maximum left will be 0. So we will store this in maximum right array, and it will be maximum left array, it will be 0. Now when our iteration will be on first index, we will run a for loop for maximum left, it will be 1, and maximum right, it will be 3. So exactly here we will run a for loop for the left part, we will get the maximum left as a 2, maximum left as a 2, and maximum right as a 3, and we can get the value of water stored, that is minimum of maximum left and maximum right, that is 2 minus this height, so it will be 1. We can store water here as a 1, right? But for each index we are running for loop for left part, for right part, that is total n number. So n, for n integers we will run n into n, so our time complexity will be n square, but we need to optimize it, right? So we can do one thing, we can run 3 for loop individually. First for loop will store the maximum left for each integer. This is maximum right. Maximum left it will store 0, maximum left 1, 1, 2, 2, like this. And maximum right will start from here 1, 2, 2, 2, 3, and 3, 3, 3 for everything. So we can get maximum right, maximum left, and we will solve by minimum of maximum left, minimum of maximum left, comma maximum right minus height of that index. So you will get the total water which we can store in that index. Now the time complexity will be n, but the space complexity is now also the big O of n. Now we need to decrease the space complexity of this. So we will do one thing. Now we will store we will take a 2 pointer, and that will be maximum left, maximum right, left end, right end. So this 4 variable will check everything, will calculate everything. So our space complexity will be big O of 1 only. How we will do this? So our left end, right end, it will start from here. Our left end LE will be here first time, and right end will be RE will be here, and maximum left also will be this one at the start time, at the initial time, and the maximum right will be also this one, right? Now we will check which one is lower in height, which is the larger in height, which is the minimum in height. This one is minimum in height because it is 4, this is 6. So we will solve for this question. Now we will check what is the maximum left for this one, that is 4, and what is maximum right, that is 6. So which one is minimum of this minus height of this, that is 4. So 0, we get 0 because minimum of this is 4 and 4 minus 4 is 0. So we will do 0 here, and now our left end will be this one, but maximum left is still this one only. Now it is 2, it is 6, which is minimum, it is minimum, right? So we will solve for this one. Now maximum left is 4 and maximum right is 6. So which one is minimum? 4 minus 2, that is 2. So we can store 2 here. Now our left end will be here. Still it is the lower than 6. So we will solve for this one. And the maximum left for this one is 4 and 6. Minimum of this is 4 minus 1, that is 3. So here will be 3. Right. Now our left end will be this one. Now our maximum left will also this one because it is greater than our previous maximum left. We will check this one on every iteration. So our maximum left will also be this one. Now which one is minimum? 5 or 6? 5. So we will solve for this one. And minimum of 5, maximum left minus maximum right, that is 6. 5 is minimum, so minus 5, that is 0. So here it will be 0. Now we will move to this one. Which one is minimum, 1 or 6? 1. So we will solve for 1. Which one is minimum? Minimum of 5, 6 minus 1, that is 4. Now left hand will be on here. So we will get the answer. You can understand, we will finally get the answer. We will run a while loop where the condition will be where left hand is lower than right hand. So how it is solving? we are taking two pointer and we are checking whether which one is lower than which one is lower in height, and we are solving for that part, and we are checking only one sided, like here we are only checking for the left part, and because it is height in short, height in its height is lower than the right hand, so we are solving for this one. We know that when the minimum is this one 4, we know, and maximum is 6, we know that there may be many value after this one right side of this index, but all there will be value 6 which will be greater than 4, so water will not flow from outside of 4. 4 at least till point of 4 there will be water, right? And we are checking from the lower height to higher height, so we are getting the all values. If we will solve from the higher height to lower height, we won't get all the values. So now I am explaining the solution. Here it is, we are initializing left hand 0, right hand n minus 1, answer as a 0, maximum left is the height of left hand, and maximum right as the height of right hand, which I have already explained you. While condition, left hand is greater and lower than equal to right hand. Maximum left is either maximum left or height of that left hand, as I have explained you. Here our maximum left was changing, right? So for this line is there. Maximum right, if it maximum height of right hand is greater than maximum right, and our answer will be minimum of maximum left or maximum right minus height of minimum of whichever height is low in size, like either left hand or right hand. And if height of left hand is lower than height of right hand, it means that we have solved for left hand, so we will increase the left hand, otherwise right hand we will decrease the right hand. Now we will return the answer. Now we will see our code part. It is exactly the same code which I shown you there.